Hello everybody, hope you guys are well and safe, and welcome back to my channel. I hope you liked my previous two videos, and I hope that you guys are watching that and following that. I'm putting a lot of effort on making these videos and have to do a lot of research on that, so I would highly appreciate if you guys like and share the videos. I have seen that on the Facebook, especially when I share my videos, many people are liking it and sharing it. Thank you so much. Thank you very much for your kind cooperation there, and this keep me motivating to make more videos. So thank you guys. This is the third episode of the HTTPS, and SSL series, and you know that I'm going through the basic stuff, how the things are working, how the communications are happening over the secure protocols, and what key algorithms we are using. And you know that I discussed different encryption algorithm in my previous tutorials. So I hope you like that, and if you're new to this channel, I would suggest you to watch my previous videos on HTTPS playlist, and then you can come on this video and you will understand it better. So without any delay, let's start. So what's the agenda today? So agenda is OpenSSL, public key infrastructure, certificate authorities, server, CA, or certificate chain of trust. So these are the agenda which we are going to discuss today. And without any delay, before I start that, let me tell you that this tutorial will be mostly based on the practical stuff, so bear with me, and just follow along, and you will understand things. Now, the very first thing is the OpenSSL. What is it exactly? So if we see for example, OpenSSL on Google, you can see that it's OpenSSL is a software library for applications that is secure communication over computer and network against need to identify the party at the other end, and it is widely used by the internet servers, including the majority of the HTTPS websites. Okay, if we see more what OpenSSL used for, is the OpenSSL is an open source command line tool, and that is commonly used to generate private keys, create CSRs, install your SSL TLS certificate, and identify the certificate. So it's a pretty handy tool. We will of course straight away jump on the practical scenario here. So you can see that I have the terminal. I'm using the MacBook, but if you guys don't have the MacBook, or if you guys are using the Windows, I would suggest you to go through different websites. I'll post the links as well. You can see it here that we have the instructions how to install the OpenSSL step by step, and I have 2-3 sites as well, but if you still don't want to read this all, I also have a video as well here how you can install the OpenSSL on Windows. So it's pretty easy. Just you can follow it here, and you'll be able to install on the Windows user. I'm using Mac, so the people who are using Mac, you don't have to follow those things. You will have the OpenSSL installed already on your systems, but just to verify, we will check if we have the OpenSSL. We will enter this, and you can see that we have the OpenSSL there. You can do the Control-C here. Now, at the very first thing we will see is how OpenSSL create the private key. So we can see OpenSSL and GEN or SA. So you see that it created a key. This is a private key, and key length, you can see it's the key length with 2048 bits. It was generated directly on the console, and you'll see the private key there. Now, of course, this is not the secure, because this is a private key, and it can be compromised. It's not encrypted, and anyone who's for example watching this video is able to use this private key, and that is not what we want to achieve, and we want to keep the thing secure. So what we'll do is that we will, let me clear the terminal here. sorry. Yeah, so what you're going to do here is that we as I mentioned, that this is not the secure way of doing the thing, so we will have to encrypt this this key. So we can go again like the same command here, and we can add a AES 256. Now this is the encryption protocol, and if you remember in the last video we discussed this and how, I mean, we discussed in a deep details there, and now we are using to generate the key, and you can see that it's asking for a password or a passphrase, you know. So we can add a passphrase here. Sorry. Yeah, we want to verify this. Sorry, we are getting an error, and it must be because our password doesn't match, so we can create it again and give it a try. That's great. So you can see that now the key is created, and here you will see the private key, and it is encrypted, and it is encrypted, and it's you can see that it asks for the password as well. So this key is now encrypted, and you can see the protocol as well, which we used here, as you can see here, and we also discussed the other protocols as well, symmetric protocols, for example DAS3, so we can use the DAS3 as well with this. So we can like 3 days, sorry, I think it's DAS3 maybe. Yeah, so it's also asking for the password, and yeah, so you can see that now we use the DAS3 protocol, and you'll see the private key is encrypted there. Usually, no sense to just see your private key here in the command line, and it should be stored in the separate file. Like you can see that I'm just it's outputting the key on the terminal screen. So for that, what we're gonna do is that we're gonna, for example, create this key, and we can use the out flag here, and we can say like private wait dot pem. All right, sorry, it's dot pem. Now what is PEM here? So it's an extension that is used for the files that include these, that have that contain the certificates, and we can use that extension for storage of the private key as well. So we can enter this. It's again asking for the password. I am entering the password here. Now you see that we have the private key generated here, encrypted private key generated here. Now it doesn't show the private key content over there, and if we want to see that, we can simply go to the private key. We can use the cat if you guys are familiar with the Unix like commands there. So you can use the cat, and you can see the content of the private network. Now here's a question maybe in your mind here, that what about the public key? Where is the public key? And the answer is very simple. We can extract the public key from this, because it is encoded in this private key. So we can extract the public key from the content of the private key, and for that, of course, we have to use the command. So we can do is, so for example, if we have, so that we have the private key stored in the private.pem file, so we can use OpenSSL, we can use like RSA and -n, that's the flag we are using, the name of the file, then we have outform flag, then we have PEM, and then we have, for example, -out, of course, to save the public key content. We can use the PIM again, and you see it's asking for the phrase for the private key, which we know. See that it's write the public key into the public.pem file. Okay, now if we want to see the content of the public key, and you can see that we have the public key here, and we use the cat command there, and you can see that we are watching the public key there. So this is a pretty decent way of generating the keys, encrypting it, and it's pretty straightforward there, and it's a very secure way to do that. We also generate the keys with the different lengths as well. So for example, if I say like OpenSSL, Gen RSA, and I can use a different length as well. So for example, 4096. You see that it was a big key, so you see it took a bit of a time to generate it, and you can see that the keys are pretty long there. Just to make it complex and more secure, we can use that as well. So you see that this is what we have here. The next thing which I want to discuss with you is, of course, we already discussed the OpenSSL and public key infrastructure, public and private key infrastructure. The certificate authority server, basically. So for example, if we go to facebook.com, for example, okay, so here's the facebook.com. Okay, all right, so here's the facebook.com. So if we go to the certificate here, and if we see the certificates here, you can see that we basically have 3 certificates here. So you see we have, for example, we can see the chain of the certificate here at the top, and you'll see the information about the certificate authority or the root authority. Okay, and this certificate authority does not usually issue the main certificate. Okay, for example, the Facebook SSL certificate. Okay, this is the root certificate authority, and we have like different you can see that parameters here where we can see different information about the root certificate. So here we have DigiCert high assurance root certificate authority, and you can see that the certificate signature algorithm, like for example, they're using the RSA encryption here. Okay, issuer, you can check this is the authority, this is the website. I mean, this is a very big, if you are a little familiar with the SSL and certificates, that the DigiCert is a very well-known certificate issuing authority there. Validity, you can see not valid before this date and after this date. So usually the root certificates have a very big validity dates. So for example, if it's 2022 now, like for example, it is a 2022, you will see the root certificate, for example, when this certificate is expiring 2031. So usually you will see that 5-6 years or maybe 10 years validity of the root certificates authority. So they're pretty big in the expiry date. The next come is the intermediate certificates, and you can see it comes in between the end user certificate and the root certificate there, and it's called intermediate certificate. So you see here that it also have different encryption. So for example, it's using the RSA encryption. Public key encryption was also used by this is the public key 2048 bits there, and we also have the policy on the website. You can go on their website and you can check that, and we also have the fingerprints. We discussed this in the last video as well. If you check that, you will understand that. And then this is the certificate. So if we go on the general, you can see that it's a static.facebook.com, means it's a wildcard SSL certificate. So if Facebook have other domains, so for example, if Facebook have a shopping.facebook.com, this SSL certificate can be used for that as well. That's why we use. So if you have a different subdomains there, usually we have, like for example, if we have a www.xyz.com and then we open a shopping business as well, we can say like shopping.xyz.com, and if we have trading company, you can say trading.xyz.com, and if we have the different domains there, we can use the wildcard SSL certificate to encrypt our websites, and this way we don't have to buy a separate certificates for each and every website here. And you see that, so this is how these things are working. And we have a root certificate, we have intermediate certificate, we have end user certificate, and they all together they build the trust. Okay, they build the trust, which we call the chain of trust, with each other to provide a secure communication over HTTP. Now the next is of course we are going to discuss the chain trust in detail. The next thing, which you can see that root certificate, intermediate certificate, and the end user certificate. So you can see that how the root certificate. So for example, in facebook.com we had the DigiCert certificate authority. So what they're going to do, like they have private and public keys, so they encrypt the certificate with the private key and create a signature there, and then they send that signature to the intermediate certificate. Now intermediate certificate will encrypt that signature and their certificate with the private key. Okay, now one thing is very interesting here. If you can see here, the owner info and issuer info. Okay, the owner info will be of course the intermediate certificate itself, but the issuer will be the root certificate here. Okay, so the root certificate will have the issuer detail here. So it will encrypt the intermediate certificate with the private key and the signatures shared by the root key, and then the whole encrypted data will be sent to the end user. Then the end user will do the same thing, encrypt the SSL certificates and the signature with their private key, and that's how they build the chain of trust. Okay, in the root and intermediate certificate. So this is very, very important. I mean, for example, if you remember in the last part, the part number 2, I showed you the hashing algorithm. If you remember the hashing algorithm, in which you saw that the data, and then they create a hash and then encrypt with the key and share it with the receiver, so that's how the chain of trust is being built. So if you don't know what's the hashing and how it's being worked here, please watch my previous tutorial and you will understand it better. Now looking at this, there is a question. So for example, how the chain of trust works. Okay, like chain of trust works with the web browser. Okay, so how browser basically trust these root certificate or these certificates. So the answer is pretty simple, is the operating system. So for example, you're using MacBook or Windows, they have a list of root certificates in the different tools. So for example, we have a keychain in the MacBook. I think in Windows they have a cert manager. Okay, so it is located in the operating system, and that's why the web browser trusts the self-signed certificates. Okay, so for example, if I open a keychain here, so I'll open the keychain and I'll show you quickly, so you can see so you see that we have a different certificates here. For example, you can see that we have different certificates. So you can see the DigiCert as well. So for example, if we go back to the facebook.com, you can see that the DigiCert certificate is there. So that's how, if they have the saved list of certificates in the operating system, and that's how they trust the certificate authorities there. So you can see that DigiCert. So you see that DigiCert Global Root CA, and it's expiring on November 10th, 2031, and I think that's what we got as well here, November 10th 2031. So you see that we have these things saved in our operating system, and that's how they trust the certificates when they verify that the browser have the root certificate from a particular organization whose root certificate is saved in our list. It will trust those websites. So that's how basically it works. It was mix and match of both practical and the theory. I hope you like this video. What I'm gonna do is that I'm gonna come up with another video to cover some of the material which needs to be done before we move further, and then of course we'll move to the practical stuff as well, how we can make our website secure, how the SSL certificates will be installed on the servers, how the practical things work. So that the next chapters and next episodes are going to be more and more interesting. Please stay tuned to the series, and you will enjoy it. Please like, share and subscribe. Please share it with your friends as well if you think that some of your friends also needed it. It will keep me motivating to make more videos. Till the next video, I will take your leave, guys, and thank you so much, and I'll see you in the next video. Thank you.